Hello everybody, this is the first of a series of tutorials that will help you understanding more deeply how Rhino and Grasshopper work. For the first video, I'm doing this in Rhino 6 for Mac, but everything that you will see in this tutorial basically applies for the Windows version. You will see some differences in the Rhino interface, but not on the Grasshopper one. So, as you know, to get started, basically you have all these commands here on the left side of the screen, also on the Windows side. On the right side of your screen, you will have all the layers and properties of the objects you produce, and also you will find the typical four view configuration, the top, the front, the right, and the perspective one that you can use to basically visualize whatever you do. So for example, if we make a rectangle, you can visualize it in all the views. If you want to maximize one of the viewports, you just double click on it, and with right click you can orbit. If you press shift and right click, you can pan, you can zoom with the wheel, and basically with all these commands here you can, for example, like fit the selected object and so on. Basically we won't get very deep into those because are not important for this tutorial. If you want to return to your four view configuration, you can do this. Also, for the ones that don't know, here you have something that is called the gumball. So basically this allows you to rotate, move, and scale according to the local object axis. So for example, here we have, if I go back, we have the green, which is the y-axis, the x-axis is the red one, and basically the normal to this work plane is the z-axis. Each object has their own local coordinate system. In this case, basically if I rotate this, if I click, for example, in this blue arc, I can rotate 45 degrees just writing and pressing enter, and the object will rotate 45 degrees. But as you can see, the axis of basically the orientation of the gumball remains parallel or in the same direction as the world frame or world coordinates. So if you want to align, and this is very important because sometimes you will basically you want to manipulate the object and local coordinates, local as the object coordinates. So if you see this white circle here, you can click on it and you can say, for example, align to object, and this will relocate the gumball and basically also reorient the coordinates of the object. So for example, you can rotate, or also if you want to move in a precise way, you can, for example, click on this arrow and say I will move 1 unit up. In this case, I'm working in, this is also important to know, if I write units in the command, I'm working in millimeters. You can change this to inches, parsecs, like you have basically all type of units. When you reorient your object, you see that this was relocated in the, let's say, if you look at the object like this, to the object's left bottom corner, right? If we want to relocate the gumball, our manipulator, to the center, it's also important to remember that we have some really nice features in Rhino in this case this is the optical snap. On Windows you will see it in the lower part of your screen, and here for example we can check or select the center. So if we go again to our white circle, we press it and we say like relocate gumball, now we have an optical snap. If I go to the border that is at center, I click, left click, and I press enter, and now our gumball is on the center. So basically now we can rotate around the center instead of rotating according to a corner. Likewise, if I want to relocate the gumball to a specific point, remember that also to get the snapping of the points, you have to select point, end, or for example midpoint, to basically have the possibility of, if I say relocate gumball, for example, now to the midpoint of this segment, I click, I press enter, and I have now a way to rotate this object here. This will not affect how you manipulate objects on inside Grasshopper, so don't worry about it. I'm going to erase this and we will get into Grasshopper now. As many of you know, you need to write Grasshopper in your command console, right? And you will see Grasshopper. Grasshopper for Mac works exactly the same as the Windows version. The only thing is that you will not have certain things such as like some specific plugins that will show up here once you install them. I will get into that in a couple of following tutorials. So basically I will recommend for some of you to install like a software package, for example like a virtual machine one, so you can run Windows on your Mac if you have it. For the Windows users, basically you have full compatibility. It's not a big deal. This is just in case you want to go into something more advanced. So for example, if some of you are considering voxel modeling, there are some plugins such as Dendro that only works on Windows. But we will get into that in following tutorials. So right now, basically this is Grasshopper. This is your canvas. Basically all of the things that you will produce will happen here, and there are a couple of things that we need to understand. You have the possibility of doing almost everything that you can do here with these commands, these buttons here inside Grasshopper, and basically they follow the same logic. For example, if I want to go to the Rhino side, and if I write line in the command console, you will get like basically like all the commands that are related to lines, or most of the commands, right? If I want to for example draw a circle, or basically have the notion, oh, I want to do something with a circle, I need to write, and you will write circle in the command console, and you will get pretty much all of the commands that have to do with that. Also like curve, for example, curve, see, this, or for example CRV, basically is that the abbreviation of curve, and you will get more commands. The same thing with surface, SRF, you will get the commands. So basically they are organized like in this type of groups according to the type of object you are creating. The same thing happens with Grasshopper. So the first tab you will get in the upper part of Grasshopper is the parameters, and here you will have something that most of the of people confuse. Here you have something that is called geometry, and in the geometry group you will have basically what we call containers. Basically these will not create geometry in most of cases. This will be some sort of like containers for instantiation of geometry from Rhino. I will explain this in a minute. On the other side, we have these primitives that basically these are type of parameters like Boolean, true or false, integers, float numbers, text, complex numbers, domains. We will see this in some other examples in a following tutorial. Also, we have input. We have number sliders that many of you know, panel where you can write, for example, messages or data. We have Boolean toggles that basically true or false, switches, a button, control knobs, multi-dimensional sliders, if you want to get like matrix values, so on and so forth. Basically a lot of possibilities to work with your nodes in Grasshopper. We have utils, or basically we have like a parameter viewer. We have something that is called Galapagos, that is a genetic algorithm solver. We can record the data. Basically a lot of things that have to do with only parameters. But what's interesting here, and I will go a little bit faster, is that you have also mathematical operations, basically like logical operations, or for example you can construct a domain, for example a range, a domain that goes from a specific number, like two numerical extremes. You can find a domain, you can include a domain, remap numbers, construct a two-dimensional domain, so on. You can work with matrices. You have operators like addition, multiplication, subtraction, division, absolute numbers, factorial, modulus, mass addition, logic operators, for example, and, or, not, so on. You have polynomials. This is very interesting for the ones that were really excited about programming. You have 3 languages supported, being the oldest Visual Basic, .NET basically was the original scripting language of Rhino, Visual Basic. You have the Python component, which is pretty powerful, but I will say like the most complete and powerful is the C#. Basically, like most of the Grasshopper components are written in C#, and it's a little bit complex in terms of syntax, but you will see that it's very similar to Java in the way that you write code. So you can basically feel or sense like some familiarity in both languages. You can also evaluate expressions or write expressions. So for example, like complex equations and so on. You have some time, trigonometry functions, and utilitarian functions. So basically here you have all of these things that allow you to do like more complex data manipulation. You have the sets. So basically here you have lists, and a set of operations that we'll see that allow you to basically manage your data, because this is basically the crucial part that you need to understand about Grasshopper, and managing how data flows through your definition, through your graph. It's really important because sometimes you can plug something in the wrong way and this will crash your computer. We have vector operations. Basically these 3 are things that you don't see exposed here on the Rhino side. These are like more under the hood operations, but here you have more of the typical commands. So for example, primitive always is about creating objects. So the difference with this part, geometry, is that these are containers, but these are basically creating geometry. Surfaces, basically you have always the primitive side. You have util that basically allows you to manage or perform like some operation, like modifying operation to those primitives. You have modeling, like freeform modeling, for example, and always you have in this at least 3 groups: curve, surface, and mesh, operation that will allow you to extract information that are called analysis. So for example, you can extract corners, you can basically get the edges of a surface, you can get the area, the volume, the centroid, evaluate a surface, so basically find a specific point within a surface or a curve or a mesh. On the mesh side, you can get like the boundaries, for example. You can deconstruct the geometry to get at the same time faces, edges, vertices. Because meshes are about triangulation, you have a lot of operations such as Voronoi, for example, or Delaunay triangulations, metabols, and so on. Also, here you have util, and then you have like other operations such as like intersections that you basically want to find. So for example, intersections defined by mathematical operations such as like the intersection between two lines, or a curve and a mesh, or a surface of a line. So basically those are defined by complex mathematical operations that are compiled on these nodes. Also, you have physical operations, basically like two B-reps. A B-rep is basically a boundary representation that could be a closed curve or a surface or a volume. We will look more into that definition. You have region operations and you have shape operations such as Boolean operations. How, for example, you will subtract one shape from another, or basically do a union, Boolean union or intersection, and so on. You have transformations, affine transformations. So basically these are specific transformations such as translation, scaling. Basically the affine transformation are compound transformation. These are rigid transform transformation that allow you to perform, like for example, like orientation, projection, rectangular mapping, and so on. You have array transformation. So basically this will create like copies in an organized fashion. So for example, in a curve, volumetric array of components, polar array, and so on. You have Euclidean transformations such as reflection, moving something, translating something, moving away according to a certain threshold, moving something to a plane, orienting something according to a frame, to a matrix, rotation in 3D according to an axis, and so on. Morphing operations, twisting a box, morphing from one shape to another, and so on. Also, you have display. So for example, if you want to paint a geometry, if you want to visualize a vector field, and so on. And this is something that comes in Rhino 6. This is Kangaroo, and this is a physics solver. It used to be a plugin. Now it's like completely basically incorporated into Grasshopper. So let's do something. Let's first to understand the difference, as I was saying, between these components and basically these three here. So always you can instantiate geometry from Rhino into Grasshopper. So basically I will draw here a point, a line, a closed curve, not fillet. Basically I will draw a nerve curve and control point curve. I will model a box. So let me move this a little bit so we can work in 3D. And also, if I right click, I can change the visualization to shaded. So basically we have these components. We can make more. Basically, let me copy this. I will copy this component up, and I will copy this here. So basically with these two curves, I can have a surface. So basically these are the most typical objects that you can find. Maybe I should add also a primitive mesh. Let me see here. Usually I work on Windows, so this is why I'm trying to find where I can find like let me write mesh. I cannot find them. Maybe here from the menu. Yeah. Let's say a torus. So also we need to understand that these are different type of objects. This is a non-rational B-spline surface. This is a nerve surface. And the main difference with this type of object, for example, this is also a 3D model, but this is a mesh. That basically this is a quad or triangular face structure, 3D structure. This is a nerve curve that basically this is defined by a complex equation according to the weights and proximity or degree according to these control points. This is a line which is also a curve for Rhino and for Grasshopper. This is a B-rep boundary representation in terms of like a 2D. Basically there is an interior region and an exterior region. Basically this is a polyline. This is a point, a zero-dimensional element, one-dimensional, two-dimensional, three-dimensional, this is a volume, right? This is also a nerve, but this is a volume compared to this. This is a B-rep, volumetric B-rep. So if we want to work with this, we need to always pick the right type of container. If we want to instantiate or have a reference from this space to this one. So if I want to, for example, produce a point or get a point from Rhino, I will get this and I will right click in the component, which now is showing this orange color because basically it doesn't have any data in it. Basically these are data containers, and when you hover with your mouse over this component, this node, you will see that it says that right now it's an empty point parameter. It has nothing in it. So if you right click, you can basically indicate or click on set one point, and you can click on that point, and that point now turns green. Basically now this point is some sort of like a ghost geometry. I will explain why. So basically if you move physically the point in Rhino, you will also be moving the reference here in Grasshopper. Now this changed to a gray state, light gray, and basically now it says like one locally defined value. This is a reference point. So what does that mean? If we go here basically and we put a panel into our canvas, you can do this by basically clicking here and then in the canvas, or just like writing panel. You will see things that more or less like are related or have like the same sequence of, or like a similar sequence of characters, and you can choose this and you will create the same. So if you connect, this is also important, you can connect by clicking here or dragging, see, dragging from the right side of the node to the left side of the following node, in this case the panel. So it says that you are actually getting a point. If I don't want to have this connection, you do the same, but you always press, in this case, for Mac, I don't remember what is the command to disconnect actually. For Windows, if you press Control, you will disconnect something. For Mac, it should be Control also. Yeah, it's Command for Mac. Basically, if you press Command, I connect with just dragging with the left click, and if I keep press Command, you will disconnect. On Windows is Control. Basically, Command is the equivalent of Control on Windows. So we know this, right? We have a point. If I want to, for example, bring the line, this is also interesting. We can basically choose line from here, put the line, right click, set one line, and here you can see that it asks me to indicate the start of a line and the end of a line, not reference the object by itself. So you see now I have a line that is indicated in green or red, because basically when objects are red are not selected. You can see now from this point. But now if I move, sorry, I extruded by mistake. If I move this, basically nothing happens to this guy. So that is important, because basically for the container, a line is either a collection of line segments, or if you do set one line, basically this will ask you to indicate 2 points. On the other hand, let's see what happens here. If I set one line, no, it's the same. So basically that is also really important. I'm going to do it again. Set one line, set the start, the end, and this object basically stays there. And if we copy and paste this component here, the panel, we can see that we have a reference object that is a line with a specific length. Let's move a little bit faster. So for example, this is also interesting. If I put the curve command, and if I indicate right click, set one curve, I can select the line, because basically for Rhino a line is also a curve by definition. So you can see now that, again, if I copy paste this component, and if I go here, it says that the object that is contained inside this node is a reference line like curve. Really important, right? And now, check this. I can select the object in Rhino, and if I move this, also this object will move, right? Not this one, which was a line, this object, but this one, which is a curve. So really important. Now, let's check another one. So for example, I want to reference with the same component, curve, this one. See, I can pick it, select it from the Rhino side, and now it says that the object that is contained here is a reference planar curve. If I select this curve, for example, and if I modify one of the control points to basically make it a 3D curve, now it changed the type of object and says that now we are working with a reference curve, not a planar curve. And that is important also according to the type of geometry that you will want to produce. So now we will generate another curve component, and for example here I copy this, and basically I'm referencing the same object. If I select this or select this, basically these are referencing the same object. That is also important. That will show you that basically most of the data that you produce or the way that you work with data is in a non-destructive way, that you can recycle sort of way your geometry or data that you produce. And that is really important compared to working in a Rhino environment. So here I just copy this container, I copied it and pasted it here, and I'm referencing the same curve. What you can do, for example, is to clear the values. I will clear the value, and basically now I have no data collected, right? Also, what happens, for example, if I erase this curve? If I erase this curve on the Rhino side, basically now you see the difference. This is a container that got the had the data erased from the Rhino side, and basically now this is showing that this is a null object. That is bad. Basically you lost the data. Here, on the other hand, I just cleared the values and no data was collected. So let's undo this on Rhino. You see this is a reference curve. And this is also another really important thing that you should remember. Remember that this first tutorial is about like good practices on Rhino and Grasshopper. So these are really important things that you should not forget. Let's say that this is tutorial 0. Also this component, if I want to save this Grasshopper definition, I can go here to save. It will ask me, how do you want to save it? The extension for these files is the Grasshopper binary, and it's GH. If I save this file only, basically I won't be saving the information contained on the Rhino file. So basically what will happen if you open this, only this file in Grasshopper, you will get an error like no data on each of these components, because basically I lost these files. So remember, if you did this, basically you model something and you reference geometry inside your Grasshopper definition, you need to save both files and open both files in order for your graph or definition. Basically, these are not called scripts. Usually people call this, oh, this is a Grasshopper script. It's not a script. This is a Grasshopper definition or Grasshopper graph. It will work basically if you open both files. But because these are like really simple data types, you can do the following. Right click, internalize data, and you see now that this change from a reference point to a vector, basically a position, an X, Y, Z position, right? And also this is important that I will explain in the last part of this tutorial, that is extending a little bit, but this is really like as a reminder that you know these things. So now, for example, I internalize the data and I can erase the point and nothing happened. You see? Because basically now I am working with this object, which is a Grasshopper ghost geometry. Again, why ghost? Because remember that we have this line here, right? And I cannot select this line inside Rhino, but I can select it from Grasshopper. The same thing with the point. So for example, if I want to remember, this is our line that we can select on Rhino, right? And if I move it on Rhino, it moves, basically it will change the reference here in Grasshopper. I can say internalize data, and hopefully I can delete this. Yes, I delete it, and basically now this is a line-like curve, but basically this is internalized and it's contained in this node. It's not anymore here on the Rhino side, right? But it's contained on this node. So this is a way of sharing your Grasshopper definitions without sharing your Rhino file. But if you, for example, reference this with like more heavy geometry, for example, a 3D model, this will also increase the size of your Grasshopper definition. And that's basically something that you don't want to do, because the beauty of this is that you're sharing basically a data structure instead just like data. So yeah, just try to remember that if something breaks when you open a file, for example, that you can find online as a reference, or for example something that you get from a classmate. And we will talk a little bit also about like legibility, or like how readable is a Grasshopper node when you produce something that basically will grow exponentially as you make more complex stuff. So let's go quick now that we understood the differences between those. Also, why I recommend using Grasshopper in Windows instead of Rhino, because even though it works pretty well, it's slower on the Rhino side. And I'm working with a really powerful Mac, basically like i9 32 gigs processor, i9 processor with 32 gigs of RAM. So basically that is a beefy, powerful laptop, and still struggles because mainly the graphics card to manage all of these reference geometries. So we have our curves, we have our points. Now what happens with, for example, the rectangle? Let's use this guy here. Rectangle, right click, set one curve, and we can still select something that is a polyline. So you see the data type here is a reference polyline curve. If we want to select, for example, this, we can do it with a surface object, because this is a surface. So if I click here, right click, set one surface, I get the surface. If I want this volume, for example, I can choose brep, boundary representation. I select this guy, and I again have it here. Let's use a panel to check the data type. Yeah, you see reference surface, and in this case it will be a reference brep. Awesome. Now the last one is a mesh. So you have a special component to bring this geometry into Rhino. This is a mesh. So if I right click this, I select the mesh, I have it here, of course, and this will be a reference mesh. Cool. Remember, if you erase something here, basically you will get a null object. So if you know that this is an initial reference, and if you don't want to basically mess with this, you have a couple of things that you could do. You can hide this geometry so you won't move it. So basically you can, from here, you can say hide, and you will hide the geometry, and you will basically get only the ghost geometry inside Rhino, so you don't move this. Or you can, for example, lock the selected objects, so they turn into like a dark gray thing and you cannot move them. Or simply, if you still need the objects